Hey makers, and welcome to another project. This is a project that I wanted to do for so long, but I was just waiting for the components to come in my country. Now, I really like electronics since I was a kid. There is something about these little components that fascinate me. They are just a bunch of components that you put together and you have a good finished product that can do miraculous stuff. For example, have a look at this Arduino. There's just a small amount of components stuck together on a board, and you will have a microcontroller that controls CNC machines. Now, for a long time, I've been stocking different kind of sensors. I've been trying them online and offline, and I really love doing that. I mean, I learn a lot of stuff that I think in the future will be helpful, to do a lot of DIY projects. And I hope in the future I will be able to share these kind of results and how I use my different kind of sensors in this channel. So if you are into that, make sure to subscribe to the channel. And yeah, before we continue this video, if you hear a dog barking on the background, well, I tried to shut it. I couldn't do it. I mean, it's the dog of my neighbors and it's kinda far away from me. If you have any practical thing that would not result in me going to jail and result in that dog stopping making noises, please let me know. I'm eager to know. So, if you've been in this channel for a while, you know that I built a DC power supply, which is this one, or at least the rest of it. If you watched that video, which I encourage you to do, you'll find the link in the description, you'll notice that the red board here is missing. Basically the board that is responsible for regulating the voltage. Well, what happened is, it's a long story. If I had to put it in a single phrase, I burned the board. Things like that can happen, okay? I tried to test the current, the short circuit protection feature, which basically you short circuit the output and the board stop providing power. Yes, it works, but they forgot to mention that if you are going to do that for more than 3 or 4 times, you will end up burning your circuit, which is exactly what I did. I mean, if you are asking me why I did it, why not? Anyhow, I decided to make another one that is, well, more efficient than this one. This one is linear power supply, and if you know something about linear power supply, well, they are not very efficient. They're around 60% or less efficient. I want something more efficient, to reduce my electricity bill money. Anyhow, in this video, I'm gonna show you how to make what we call a switching power supply, and it's gonna be modular, meaning that there's not a lot of soldering involved. It's just connecting some wires and a module. This is the module. Now I'm gonna show you all the components. So you need this module, which I'm gonna talk about in just a minute. You need a multimeter, you need 2 potentiometers, and a power supply. For power supply, you can either go with 12 volt or 24 volts. Now I'm going with 24 volts, and let me explain why. Now this is a buck converter. A buck converter will basically take an input voltage, for example our 24 volts, and will output something between 0 and that voltage, basically that 24 volts. If we are going to put the 12 volt, we will have a margin between 0 and 12 volt, because this is a buck converter. Now if you are familiar with a small model that if you are, for example, you put 3.5 volts and you will have 12 volt, that's a boost converter. Now if you are familiar with a model that you can just put 12 volt and have something between 0 and 24 volts, that's a buck boost converter, which basically a buck and a boost stacked together. Now because this is a buck converter, I am limited to the voltage that I apply in the input. That's why I'm going with the 24 volts, so I have more margin on my DC power supply. Of course, we need a multimeter to measure the voltage and the current. We need 2 potentiometers to control the voltage and the amps. Now notice here I'm using regular potentiometers. Yes, there are better solution, which is this potentiometer that you see on the screen, which is for precision, meaning that, for example, this one is 20k. To go from 0 to 20k ohm, it's just one turn. Now the blue one is for precision, so from 0 to 20k you will need to do 10 turns. So you can imagine that you can have more control over your power supply. But the downside is they cost a lot of money. They're hell expensive. And to be honest, buying one will cost the same money for buying this DC converter, which it was not cheap. Okay, it was around $10, and you know, consider that my country is poor, $10 is a lot of money. Okay, let's get that straight. Okay, so for the connection, it's gonna be easy. See, because this is basically our whole power supply. You are just going to put these together. I mean, I should edit the video and, you know, show you some crazy editing where I just, you know, take this box and do something like this, and they will just, you know, magically connect to each other. But hey, I don't know how to edit. Be easy on me. But what's gonna happen next is very simple. I'm gonna take those wires, connect them to the output. I'm gonna remove this bulky thing, connect this here, connect the input to this socket, add a fan that I control with this switch, because there is something that it annoys me with power supplies. They are very loud, at least the cheapest one. You see, for example, if I'm going to use a lot of power from this little device, it's gonna get hot. I understand that. But what if I'm using only like 0.5 amps at 5 volts? Like, I only want to power this thing on to, you know, read from a sensor or something. I don't need a fan to constantly blow on this thing. And why I'm recording video like this, you can imagine how annoying it is to deal with this in the software. And I mean, in my voice editing software, it's gonna be a lot of pain to try to reduce that noise coming from the fan. So having switch on off can be very helpful. Of course, if you don't have the record issue and you don't care about the noise, you can just forget about adding a switch. Now that's what's gonna happen. So in the next, I don't know, 10 to 30 seconds, depending on my mood while I edit this and how far I'm gonna speed things up, you'll see me just connecting some wires. And yeah, before I forget, this is the schematic for this power supply. As you can see, it's very simple. Anyone can do it as long as you are careful while using your hot soldering iron. And if you don't know how to use it, ask someone. And yes, before I forget, we are dealing with mains voltage here, at least the part where you need to connect it to the socket. So as long as you don't mess things up, nothing bad will happen. But hey, just double check it, triple check it, quarter check it if you need, and maybe ask someone who is old enough, if you are not, to help you in the soldering process. And with that, everything will be done. So yeah, you can go watch my other video if you want, or you can just keep watching this because I need that watch hours view so I can put ads on this video, so I can probably get some money to buy new parts. Anyhow, yeah, you're free. So the next part will be just me putting some music and soldering this, and I hope it's gonna work from the first attempt, which is pretty rare. I'm not gonna lie to you. But yeah, so 1, 2, 3, let's start. You hear that? This is the voice of success. So I have a fan, I can turn it on and off. This is their hole for it, and this is another hole, so the air can, you know, freely, moves. Now I'm gonna close this. Let's have a look inside of it. Actually, let's run a test first. So this is the output voltage. I can go from 1.1 to 24.7. If you notice, it's not actually 0, it's 1.1. Yes, this is something that you have to deal with when using DC to DC converter, especially the buck converter. It does not go all the way to 0. And of course we can adjust the current. So let's run a small test on this motor right here. Okay, so I'm gonna put a wire here and another wire here. Okay, so we don't have, okay, so we can see that at 1.1 it actually draws around 2 amps, which is scary. Okay, I'm gonna, oh man, this thing draws 3.3 amps. Can you imagine how strong this thing is? Of course we can limit the current, so right now we are only allowing 0.5 or 0.8 current to draw. You can feel it like it's vibrating, and of course we have 0 at the voltage because we decreased the current all the way to 0. And here we can increase the voltage. Yeah, I mean, yep, you can tell the voltage works and the current works, so everything here works. Let's close the fan and close the system, and let's have a look inside. Well, it's not like I have treasure here or anything, just the circuit that we talked about. And spoiler alert, it's very ugly, don't blame me on the comments. Yeah, as you can tell, I changed the lighting because, yeah, I was filming in the morning and now it's night time. Okay, so this is the system. So we have the charger, we have the module, the buck converter, and we have a fan that is blowing the air directly to the buck converter, so you know we don't have a problem with overheating and voltage drop. Because here's the thing, these type of drivers, if they got hot, not drivers, I mean the MOSFET inside of it, this model and the similar models, when they got hot, there are two options. One, they will burn itself down, and basically you have to either change the transistors or throw this away, or they will go into protection mode, which is thermal protection mode. Basically, when they heat up to certain temperature, they will just shut themselves down, you know, to protect themselves from the first option, which is destroying themselves. Now, this is the end of this video. I know it was not that exciting. I mean, I'm too lazy to edit, and I'm actually right now I'm making my own CNC machine, so I'm actually investing all my free time on improving the CAD and everything else. I need this to run some tests on the motors to know exactly what torque I'm dealing with. Oh man, I actually what? Oh man, this I put this in a bad position. Damn, I actually cracked the box. Holy bananas. Okay, let's see. This is better, and this is better. Okay, this was the best fail to close the video with. Now, I hope you enjoyed something, and I hope you learned something. And as always, stay safe, and yeah, you can subscribe to the channel. It's free anyway. So yeah, see you. Peace.